Hey everybody, this is Larry. This is the 8th day of the June Leetcode Challenge, week 2. Let's get started. Oh, okay. I should just load it. Okay. Power of 2. Hit the like button, hit the subscribe button. Let me know if you know, enjoy this or whatever. Okay, power of 2. Given an integer where the function determined this is a power of 2. So this one, there's a lot of ways to do it. Naively, you can just check whether, keep on dividing by n and checking whether it is equal to 1 if, basically in binary, any power of 2 will have just be 1 with a lot of zeros afterwards, right? So that's kind of what we can do, and that's pretty much it, really. You just divide by 2 to chop off the zeros and checking, make sure that's 0, and then 1 at a time, and it will have a 1 at the end, right? So that's kind of our algorithm. What I'm going to do is, that's making sure about the input. Input, assuming it's an integer, or an in 32-bit, or even 64-bit, and for Python, doesn't really matter. So one thing to notice is that, and you may see this trick somewhere, so that's why I'm going to do it and explaining a little bit. But if you want to do it just to brute force, or not even, it's not even brute force, it's just a standard for loop or while loop. Just do it that way. Divide by 2, check that is the last digit 0, and then keep on chopping it off until you have exactly 1 at the end. The trick that a lot of people do and that you'll see is, I don't know, and I don't know if I advocate this per se, but it is something that you may see in other people's code, is that, well, this is the power of 2, right? Well, given the power of 2, what is the power of 2 minus 1? Well, the power of 2 minus 1 is just this, right? All the way, all ones all the way. Maybe I'll even draw a few more here, right? So then in this case, given these two numbers, binary numbers, you can see that if you add them together, then this is all zeros, because by definition, the first digit is going to be 1, and then they're all going to be zeros, and then in the second number, which is n minus 1, will be 0 in the first digit, and 1 in all the other digits. So that's kind of the logic behind this code, and that's what I'm just going to write. It's a pretty quick and simple thing. I don't know if I advocate it, but if you see it and what did I click on? If you see it and you read it, then now you know why they do it that way. But yeah, let's try some numbers. Does it have to be positive? No, so okay. I don't think 0 is a power 2 though. So what's another 256? And just random numbers. And maybe and say 2 just for fun. Okay, so we definitely have some wrong answers. Oh, I'm just being stuff. I meant to say this is equal to 0 because, as we said, but I think I was just rushing it slightly. That's my bad. But yeah, but we just have to check that this statement is 0. And yeah, so we're mostly right, except for the 0 case. I'm just double checking that it's true for the other cases. So why is this false for 0, right? This is false for 0 because 0 is, well, 0 is just zeros, and -1, without getting too complicated about it, it is you get the 2's complement, so it's all ones, even the sign bit, and then that's going to be 0 as well. So that's just, and I don't know if that's part of the input, so that's something that you have to think about, whether negative numbers make sense. Well, negative numbers don't really on power of 2's in any case, right? So let's just do if n is less than 0, or you go to then return false. Okay. So it really depends on the domain of your problem, which means the inputs that are valid, but it doesn't tell you, so that's why I'm not sure. But we could verify that, and now it looks good. Let's submit. Cool. Yeah. And so what is the running time complexity and the space complexity? Well, space is just O of 1, I suppose. And why did I say that? Because because the size of your input is going to be, it's really nuanced, right? Because the size of your input is actually the number of bits. That is what n represents, and the number n can be represented as log n bits, right? Or with log n bits or binary bits. But and what I mean is that, and for most arguments, you could say that it's constant because it's 32 bits or 64 bits or whatever integer. But to be pedantic and nuanced, because when you're dealing with input that is literally just a number, then the number of bits really, in terms of analysis, is something that I think about, right? So in that sense, I mean, for most purposes, you can say it's all one, but just keep in mind that in the terms of the number of inputs bits, this is O of, I would say O of n, where it's linear, or maybe a better way of saying it is linear in the size of the input size, right? Because we have to allocate an extra variable, which is also equal to the input size, right? So yeah. And similarly, what is the one-time complexity? Yeah, okay, you can say, oh, one effective, which is true, but also technically, again, n minus 1 is going to at worst be O of, it's going to be linear because it goes through every bit once, roughly speaking. And then this AND statement also obviously goes through every bit one by one, maybe in parallel, but still, it looks at each bit at least once, so it's going to be linear in the size of the input. But that's just being pedantic, because the input is going to be an integer. In theory, it is on the order of 32 operations because it's 32 bits, which is all of 1, right? Anyway, that's just being pedantic, just something that to think about, and depending on maybe your interviewer, and these things are nice to clarify because some people are more pedantic than others, for better or for worse. And it is interesting to kind of think about things and put in terms of the input size, which is more mathematical. But yeah, cool. Yeah, that's all I have for this problem, I think. I mean, I just wanted to explain this a little bit. By itself, this is probably not going to be an interview question, but it might come into a lot of places, especially in competitive programming, where you're just like, okay, there is some like thing with power of twos and divide and conquer maybe and something like that, right? So then you see people do this, and now you know why. And definitely you could have done it this other way with the while loop or for loop or whatever. Anyway, cool. That's all for this problem. I'll see you tomorrow. Have a good day. Hit the like button and hit the subscribe button. Bye bye.